While the world is still debating one major question, when will artificial intelligence reach human-level intelligence? Google DeepMind is already asking a much bigger question. What happens after AGI? For years, artificial general intelligence, or AGI, has been considered the ultimate goal of AI research. The idea is simple. A machine that can understand, learn, reason, plan, and solve problems across a wide range of tasks at a level comparable to humans. But a recent DeepMind research paper suggests something much more ambitious. AGI may not be the destination. It may only be the beginning. Instead of focusing only on creating human-level AI, DeepMind is exploring the path from AGI toward something far beyond it. Artificial Superintelligence, or ACI. A future where AI systems could outperform the combined abilities of the world's greatest experts across science, engineering, medicine, and many other fields. This is not a prediction from a science fiction writer. The paper was created by some of the most influential researchers in modern artificial intelligence, including Shane Legg, DeepMind's chief AGI scientist and co-founder, and Marcus Hutter, the researcher behind the famous AIXI theory of universal intelligence. When researchers at this level publish a roadmap about what comes after AGI, it is worth paying attention. Because they are not just asking, can we build smarter AI? They are asking, how does intelligence itself evolve once machines become capable of improving and scaling it? A paper written for the AI era. One of the most interesting details appears right at the beginning of the paper. Instead of starting with a traditional academic introduction, DeepMind includes a section called Summary Instructions. But these instructions are not written for human readers. They are written for AI systems. The paper provides guidance for AI assistants that may analyze, summarize, and evaluate the research. This detail reveals something important about the world we are entering. AI is no longer just a tool that reads scientific information. AI systems are becoming participants in the process of understanding and organizing knowledge itself. The way we write research is beginning to change because machines are becoming part of the audience. Understanding the intelligence ladder. Before discussing what comes after AGI, we need to understand how DeepMind defines different levels of intelligence. The paper separates intelligence into three major stages. Level 1, Artificial General Intelligence. AGI is often misunderstood. Many people imagine AGI as a machine that is instantly smarter than every human. But DeepMind describes it differently. AGI is closer to the average human level across a broad range of cognitive tasks. An AGI system would be able to reason, plan, learn new skills, use tools, communicate effectively. It could perform many tasks that a human worker can do. But it would not necessarily be a genius. It would be capable, not extraordinary. Level 2, Artificial Superintelligence. This is where the scale changes completely. ACI is not simply an AI that is slightly smarter than a person. DeepMind describes it as a system capable of outperforming massive groups of highly skilled experts working together over long periods of time. Imagine thousands of the world's best scientists, engineers, and researchers collaborating for years on a single problem. An ACI system would potentially match or exceed that level of collective intelligence. This changes the entire concept of productivity. A human expert is limited by time. They need sleep. They need to communicate. They need years to develop expertise. An AI system does not have the same limitations. It can operate continuously, copy knowledge instantly, and coordinate with other AI systems at digital speed. Level 3, Universal AI. The final concept discussed by DeepMind is Universal AI, based on Marcus Hutter's AIXI theory. This represents the theoretical maximum of intelligence. A perfectly rational system capable of making optimal decisions in any possible environment. However, this is not something we can realistically build. The computation required would be beyond physical limits. It is similar to the speed of light in physics. We can approach the limit, but we cannot actually reach it. The 4 paths from AGI to superintelligence. So the biggest question is, how do we move from AGI to ACI? DeepMind outlines several possible paths. The first is the most familiar one: scaling. For the last decade, AI progress has followed a simple formula: more computing power, more data, bigger models. This approach has produced incredible results. But DeepMind explores what could happen if AGI itself becomes scalable. Imagine that the first generation of AGI is expensive and limited. Perhaps only 1,000 copies can operate worldwide. But if computing efficiency continues improving rapidly, that number could grow dramatically. Within a few years, we could potentially move from thousands of human-level AI systems to millions or even hundreds of millions. But the important difference is this: millions of AI systems are not the same as millions of humans. Human organizations are slow. People need meetings. Communication takes time. Knowledge spreads slowly. AI systems can exchange information instantly. If one AI discovers a better solution, that knowledge can potentially spread across an entire network. This creates something very different from human intelligence: a coordinated digital intelligence. And that could become one pathway toward ACI. The data wall and the limits of scaling. However, there is a major problem with simply making AI bigger: data. For years, AI progress has depended on a simple idea: give models more information, more computing power, and more training. But high-quality human data is not unlimited. The internet contains enormous amounts of text, images, scientific papers, and code. But the best training data is becoming harder to find. This creates what DeepMind describes as a potential data wall. The challenge is that replacing human knowledge with AI-generated data is not as simple as it sounds. If AI systems train only on their own generated content without careful verification, they can begin repeating their own mistakes. Over time, quality can decline. To move beyond this limitation, future AI systems may need to become more active learners. Instead of simply absorbing information, they may need to run simulations, perform experiments, test ideas, learn through trial and error. Similar to how humans discover new knowledge. This could change AI from a system that studies the past into a system that actively creates new knowledge. Beyond transformers, the search for new architectures. Another possible path toward superintelligence is a fundamental change in AI architecture. Today, most advanced AI systems are built on the transformer architecture. Transformers have been incredibly successful. They power many of the world's most capable language models. But they also have limitations. They are excellent at recognizing patterns and predicting information. However, researchers continue to explore whether new approaches are needed for deeper reasoning, long-term memory, planning, understanding complex environments. Future breakthroughs could come from completely new architectures, specialized hardware, or even new approaches inspired by neuroscience. The interesting part is that we cannot predict exactly when this will happen. A true breakthrough is difficult to forecast. Because if we already knew the solution, we would probably have already built it. The possibility of recursive self-improvement. Perhaps the most discussed idea after AGI is recursive self-improvement. The popular science fiction version is simple. An AI becomes intelligent, improves itself, and rapidly becomes something far beyond human understanding. But DeepMind presents a more realistic possibility. The future may not be one AI rewriting itself overnight. Instead, AI could gradually automate the entire process of AI development. AI systems could help design better algorithms, discover improved architectures, create more efficient chips, optimize data centers, generate scientific simulations. In other words, AI could begin improving the tools used to create the next generation of AI. This would create a powerful feedback loop, a digital evolution process. Much faster than biological evolution because software can change in seconds, while biological evolution requires generations. However, there are still physical limits. Even a superintelligent AI cannot ignore reality. A better chip still needs to be manufactured. A new medicine still needs laboratory testing. A larger data center still requires energy and cooling. The digital world moves extremely fast, but it is always connected to the physical world. The power of AI swarms. Another fascinating possibility is not a single superintelligent AI, but millions of specialized AI agents working together. Humans already operate this way. Companies, universities, and governments are examples of collective intelligence. No single person can build a modern smartphone alone. It requires millions of people with different skills. But human collaboration has limitations. Communication is slow. Information gets lost. Organizations become inefficient. AI agents could work differently. They could instantly share knowledge, create specialized teams, and coordinate at digital speed. Instead of one giant AI brain, the future may look more like a global network of intelligent systems working together. A digital civilization of specialized AI agents. The reality check: why AGI is not magic. Despite all the possibilities, DeepMind also emphasizes something important. Superintelligence does not mean unlimited power. Even the smartest AI system must follow the laws of physics. Information cannot travel faster than light. Computing requires energy. Machines generate heat. Some problems remain extremely difficult even with massive intelligence. An AGI system could become incredibly powerful. But it would still exist inside the same universe as humans. The real race begins after AGI. The biggest message from DeepMind's research is this: AGI should not be viewed as the finish line. It may be the moment when intelligence itself becomes scalable. For thousands of years, human progress has been limited by biology. We can only learn so much. We can only work so many hours. We can only communicate at human speed. AGI could change that equation. Once intelligence becomes something that can be copied, improved, and coordinated, the pace of innovation could accelerate dramatically. The future of AI will not only be about creating smarter machines. It will be about building systems that can discover, create, and collaborate at a scale humanity has never experienced before. AGI is not the end of the story. It is the moment the real race begins.